Here in the US and many parts of the world, electricity is the biggest enabler of what we call civilization. And yet, a lot of the things we take for granted, we don't even consider how those are dependent on electricity. And because electricity is basically always there with the flip of a switch, it's easy to take for granted. Hi, I'm Jeanne Harshbarger, and I'm an electrical engineer. I work at Snohomish County Public Utility District, and I'm the manager of system planning and protection. Our group, the Planning and Protection Group at the PUD, is in charge of a couple different aspects of providing electric service to our customers. So the planners deal with more balanced, steady state conditions that kind of change slowly over time. So they're concerned with like what's the peak usage on the system, is our system sized to handle that. What they do is forecast where the load is going to show up or increase in different parts of the county. Will the system be capable of delivering service to that part of the county? Will it have low voltage? Will it have overloads? So they identify the possible problems that could come with increased growth, and then they identify different options for solving it. They get a cost estimate for each one, and then they pick the most cost-effective one, and then they make plans to spend money just in time to reliably serve the load, but without spending more of our customers' money than we need to. And then the protection group has this slightly different focus. They don't study so much the steady state. They study what goes wrong when, or what happens when things go wrong. If a tree hits the line, if a car hits a pole, if an animal gets in the line, whatever, what's going to happen? And so analyzing the system to figure out, is something wrong? If something is wrong, what are you going to do about it? And so generally the result of their work is to turn out the lights. So the planners are there to make sure the lights or the power is always available. The protection people end up having to turn the lights out to prevent equipment damage and make things safe for the public, for personnel, things like that. So the protection group does studies to determine if something happens on the line, if one line falls on the ground, if two phases slap together, if they contact some foreign object, what could be the difference in currents and voltages. So they set relays based on expected conditions for those odd faults, and they will open up to, or they will send a signal to the circuit breaker to open, de-energize the fault, and make the system safe, prevent damage to equipment, and make it safe for customers. So they're monitoring all the time, and then when some value exceeds the set threshold, then it starts timing and will eventually, if needed, send a signal to the circuit breaker to open and de-energize the circuit. So this is a picture of a record that a relay caught just when a fault was happening. So it's recording continuously. This part of the graph, you can see the current is low. It's just serving load. It's well within its current carrying capabilities. The voltages are nice and balanced. They're at full voltage. Everybody is pretty happy with this sort of operation, but something happens that causes two of the lines to slap together. Maybe a tree came down and brought the wires close to each other. Maybe a car hit the pole and they bounced together, something like that. But you can see that the current jumps up to about 50 to 100 times what it was before that. And so clearly that's not good. If you were standing under the line, you would see a big flash, you would hear an explosion. It would be pretty dramatic, but the relay is there, and it detects the fault and it issues a trip to open the circuit breaker, and you can see that pretty quickly it goes back to normal conditions. So all the customers that are beyond that protective device I mean, the result for them is the lights go out, their TV is off. If you were working on a desktop computer, you just lost all the Excel since last time you saved. It's pretty dramatic. And so what you have to do then is pick up the phone and call the PUD, let them know your lights are out. And they're getting calls from a lot of customers. So they'll send a serviceman out to determine, what happened, what's needed to fix it, and they do implement, restoration procedures. They get a crew rolling out there with all the material they might need to fix it. But it could be an hour or two, or if it's a storm, it could be a while before your lights are back. This is a video of kind of an unusual way for wires to come in contact with each other. There are so many birds on the wire that the wire is, you can see it sagging. When they all leave, the wires fly apart and then they swing together, and that's what created the big explosion and flash. And everybody downstream of that protective device lost power. At the PUD, we have what we call the test lab, where we have one of every different kind of protective device that is used in the system. And this gives us the opportunity to try out different settings, different logic, make sure everything is going to communicate well between devices and between devices and our control center. And so protection is a pretty large team of people. There are the substation people that build it and maintain it. There are the relay technicians that program it. And of course the protection engineers that model the system and make the settings that go into the relay so that it responds properly under all the different conditions it could be required to protect for. So these are test switches that inject the voltage and currents into the relay. So here it doesn't have a circuit breaker to trip, but we can, see that the output closed, make sure that's what was intended to happen, and it's just wonderful to be able to test things out here close to the office where it's controlled conditions. Before we get way out in the county at some remote location, we'll be sure to have everything we need with us because we had the opportunity to test it ahead of time. Okay, so we started off talking about the fact that I'm an engineer. So what does an engineer do? That's the amazing thing. There are different types of engineers. There's electrical engineers, like I am. There are civil engineers, mechanical engineers, chemical engineers, aeronautics engineers, environmental engineers, a lot of different fields. But even within electrical engineering, there is such a wide scope of work styles. Some engineers are doing design, and they can drive around town and see things that they have designed doing their job day in and day out. Or there are jobs that are a little more analytical, maybe sitting at your desk the whole time, using computer models, kind of abstract theoretical stuff. So that's the great news. No matter what you like to do or what kind of work environment you like to have, there is some kind of engineering that could be a good fit for you if you enjoy math, science, logic, and problem solving. I have a Bachelor of Science degree in electrical engineering as well as a Master's of Science in electrical engineering, and both are with a power emphasis. The skills that are important for my job are ability to use math and science, logic, and of course people skills. You can never go wrong with being nice to people, being polite, understanding, and valuing different opinions and approaches to solving problems. It's unique because a lot of people don't even realize that it takes people and a whole career to provide electricity because it's built into our society that it's easy to take for granted. The best part of my job is the people I work with. In addition to that, I love problem solving, and making things better just brings a lot of satisfaction. It's technically challenging, but very rewarding. The toughest part about my job is when things don't exactly go right. But that also provides an opportunity to learn. If you never fail, you never have an opportunity to consider what might be a better way to do it, and just figure out, what went wrong and what can you learn from it, how can you make it better next time. Well, has a pretty big impact on the community. Electricity is one of those things that enables a lot of things to happen, economic development, just what we call civilization, makes life easier, better, and more fun. Oh, well, I did get good grades. I loved school, and I just had great teachers that made it fun, and they kind of gave me the reason why I needed to know this stuff and connected the dots, and learning came naturally for me. Electricity is always there, and when it's not, you need to have a plan in place, because there are times when you'll be without power for a short while. It's unfortunate, but the equipment that serves electricity in the county is kind of out in the weather, subject to forces beyond our control. But with one phone call to the PUD, help is on the way, and they will restore power as quickly as possible.